But thank you for sharing. So I guess we can just jump straight into the questions then.
Let's have a look at dividing fractions, right? A half divided by a quarter.
Yep.
Okay. Procedures first, understanding second approach. Right, students, we're going to now look at dividing fractions. When you divide fractions, here's what you do. And here's our example: a half divided by a quarter. You take the second fraction, you invert it, and you change the division sign to a multiplication sign. So your second line is a half multiplied by 4/1, and you do your numerator and denominator and cancel down, and we've got 2. Why? Why do we invert and multiply? How does it 2? It doesn't make any sense. How the heck can a half divided by a quarter equal 2? Do 10 questions, you'll get it, right? There's no way that 80% of students will get any sense of understanding what the heck is going on. So how do you deal with that? And it's difficult to explain why you invert and multiply, right? So you don't bother explaining. You have a look at patterns. And so you're looking at, let's take, divide something by 4, now divide it by 2, now divide it by 1, now divide it by half, divide it by, you see the pattern, and they can see what the predicted answers are, right? So that's one way. That's not the whole thing, but that gives them an idea. Let's now play around with some diagrams and see how this works. What does divide mean? Oh, it means how many, like what does 4 divided by 2 mean? Or how many 2's in 4? Right, so what's the answer? Well, that's 2, okay. So what do you think a half divided by a quarter would mean? Oh, it's how many quarters are in a half. Right, let's draw a half. How many quarters? Before you get the question, it's 2, because now they understand it. So then your first exercise, right, and this is against what the apparent research. Problem with research is you can pretty much go to the net and find anything to back up your answer. To me, this is common sense, right? What I'm explaining right now.
Yeah.
I'm not saying we shouldn't do research. I'm just saying let's not be pedantic about one's got to come before the other. So I think it makes sense to work with the concepts first in this case. So my first activity, I'm going to have a whole lot of shapes on a page that they don't have to spend hours drawing, so they're ready to go, and maybe with questions. And so they're doing questions like, 1 divided by a half, a half divided by a quarter, blah, blah, blah. Ones that are easy to just add extra lines to the diagram and work out what the answer is, right? That might take 5 minutes, 10 minutes. Who knows? Maybe you get the ones the kids who've finished, make up your own. Make one up for your partner. Not too hard, though. Make it, Then the next worksheet series, same thing, but now they've got to do that and the procedure. But to get the procedure, I'm not going to teach it and say, right, now we know, we now understand this. We know what answers we should be getting. How the heck can we get, what do we have? A half divided by a quarter. How can we possibly get 2 out of that? See if the kids, and so you can do anything you like. Let's just play around with it and see if we can get the invert and multiply. Maybe we will, maybe we won't. Maybe some students already seen it and we'll volunteer it. But that's a more collaborative way of getting to the procedure. Now we've got a procedure. Now you're going to do both. So you're going to do it side by side. You're going to do the diagrammatic answer and the procedure answer. And then you just go into the procedural, but then you can tackle the, what's a 20th divided by a half, or a half divided by 20th, and ones that are more complicated, that are too messy on a diagram. So that's an example of an understanding first, procedure second approach in action.